For this problem, we're going to solve a quadratic formula involving complex solutions. So first off, we need to identify our ABCs. A is always next to x squared, in this case it's 1. B is always next to x, this is 5, and C is always hanging out alone, 9. So we're going to start off with our quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a is equal to x. So now it's a game of plug and chug, and we're going to put our numbers in. When we do that, we get negative 5 plus or minus the square root of 5 squared minus 4 times 1 times 9, all over 2 times 1. Simplifying, we get negative 5 plus or minus the square root of 25 minus 36 all over 2. So now that's going to be the same as negative 5 plus or minus negative 11 all over 2. Here's where we run into trouble. There's that negative 11 in our radical. So in order to deal with this, we're going to use what's called an imaginary number. Okay, we denote imaginary numbers with an I, and we say that that's equal to the root of negative 1. And I squared is then equal to negative 1. So let's see how that plays out. So the square root of negative 11 is equal to the square root of negative 1 times the square root of 11. So let's rewrite what we have. As a result of our imaginary number, our new solution will be negative 5 plus or minus root 11 I all over 2. And that would be our final answer. Notice that this is a complex number written in the form a plus bi. Okay, so that means that our numbers will always go in front of that I.